Hello 3D printing friends! Today on the BV3D channel we'll get an early look at the Creality Sermoon D1 3D printer. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. Hi, welcome back. Hey, if you're new here and you're wanting to learn about 3D printing, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, so today we're getting an early look at the Creality Sermoon D1 3D printer. This is an almost fully enclosed cube style printer in the bed dropper style, like the Ender 5 series, the Ender 6, the CR5 Pro, and the CR200B. It seems like Creality has several cube frame printers on the market these days or coming to market soon. My friends Jim at the Edge of Tech and Chris at Kersey Fabrications just recently did videos on some of those. Chris live streamed the unboxing and building of the Ender 6, and Jim's got a video about the CR200B. Links are in the description, so you can go check those videos out if you haven't already seen them. Before we get going, I want to point out that this is a pre-release version of the Sermoon D1. Creality may change things here and there on the production model, so I wanted you to know that going in. Let's talk about the printer's features for just a moment. So the most obvious feature of this printer is its cube-style frame. The industrial design on this printer is stunning. Where the Ender 3 and Ender 5 series have a decidedly utilitarian look, this thing is downright gorgeous. The frame's satin silver finish contrasts nicely with the black of the interior, and the side panels are, clearly, designed to showcase what you're printing. Like when you finish a print job, it's almost as if it's in a display case. It comes with the usual kit of tools, plus a few extras, such as a nozzle wrench and another wrench that looks like it's sized to fit the heater block. Interestingly, and different from the other Creality printers that I own, the X and Y axes move on smooth rods with cylindrical bearings. On this printer, the bed raises and lowers, while all the X and Y motion happens up at the top. And it's not a Core XY design, it's still a Cartesian design, in which each axis has its own dedicated stepper motors. So the X-axis has its own stepper motor and it moves the entire Y-axis assembly left and right, so that the Y-axis with its own stepper motor can move the printhead forward and back. Yes, it's different from, say, an Ender 3 where the Y-axis moves the bed back and forth, and the X-axis is mounted to the Z-axis so that it can move the printhead left and right and up. But it's not Core XY and it's not HBOT. Both of those motion systems have complex belt paths, and it takes two stepper motors to move the printhead anywhere, even in a single axis. And if you don't know what it means for a printer to have a Cartesian motion system, or Core XY or HBOT, that's perfectly okay. These are just mechanically different ways that a printer can move the printhead around to do the job of printing. So in addition to being a Cartesian printer in a cube-style frame, it also features a direct drive extruder, a filament runout sensor, and a 4.3-inch color touchscreen mounted at a user-friendly 45-degree angle. And the clear plastic side panels, back panels, and doors let you see what you're printing without a lot of, well, printer getting in the way. The printer also has a main board with silent stepper drivers on the X and Y axis, but not on Z. During the normal course of printing, that is once a print job is underway and filament is being laid down, the printer's motion is pretty quiet and unobtrusive. But when the bed is taking the elevator to the basement or heading up to the penthouse suite, everybody knows it's happening. Okay, I admit I'm exaggerating just a bit, but I don't get the design decision to not include silent stepper drivers on the Z-axis when you're already putting them on the X and Y axis. But that's just me. The printer's overall size has a footprint of 500 millimeters by 500 millimeters by 531 millimeters tall, but that figure doesn't include the spool holder sticking out of the side of the printer or the extruder and cables and filament that stick out of the top. It's got a generous build volume with 280 millimeters on the X-axis, 260 millimeters on the Y, and 310 millimeters on the Z-axis. Speaking of the Z-axis, the printer has dual Z-axis motors and lead screws, so the bed is supported on the left and the right sides when it's in operation. The nozzle's temperature maxes out at 250 degrees Celsius, and the bed tops out at 100 degrees. The bed is manually leveled, there's no BL touch here, but it's got the good stiff yellow springs and big adjustment knobs to make leveling adjustments easy. The print surface is Creality's carborundum glass. This is supposed to release the print once it's cooled back down to room temperature. Depending on the filament, sometimes I'll add a quick layer of glue stick to the glass to help with adhesion, or in the case of PETG, to act as a barrier, because PETG likes to stick too well to glass. On the Sermoon D1 so far, the glass has released prints easily, and I really like that. The Sermoon D1 is easy to assemble. In fact, I would argue that it's easier to assemble than an Ender 3. And Creality has a pretty good how to put it together video on the SD card, so I'm not going to compete with that. But here's a quick overview. Attach the 4 vertical extrusions to the base, attach the top to the extrusions, add the end caps, connect the wires, and then add the back panel, side panels, and doors. Not counting the screws for the panels and the doors, it's pretty much just 8 big bolts. 4 to attach the extrusions to the bottom, and 4 to attach the top to the extrusions. Total assembly time is in the 45 minutes to an hour range. The only gotcha that you need to watch out for during assembly is to pay close attention to the assembly drawings to make sure that you get the vertical extrusions in the right place and the right way up. Oh, and the Z-axis lead screws are hiding in a pair of 2040 extrusions. Creality's video doesn't show that, and the instructions don't tell you that. So if you get to the part of the instructions where you're supposed to install the lead screws and you can't find them, look inside the 2040 extrusions that the bed platform rides on. There were a few problems that I encountered though. Despite being very well packaged with a thick cardboard box and dense foam padding, a few things were damaged during shipping. The 10-conductor ribbon cable that brings, among other things, the X-axis stepper motor signals up to the top of the printer, that got pinched between the bed frame assembly and the base of the printer, and that cut one of the conductors. Now fortunately, I'm handy with a soldering iron, so I was able to repair that damage, and Creality is sending me a replacement cable. When it arrives, I'll save it as a spare in case my repair doesn't hold. The Z-axis limit switch was also damaged. The edge of the plastic broke during shipping, allowing the little silver paddle thing to fall out. I repaired the switch body with super glue and the end of a toothpick to hold the paddle in, but this repair is not perfect, and so along with that ribbon cable, Creality is also sending me a replacement switch module. The last bit of shipping damage is that the Y-axis limit switch's little silver paddle thing is slightly bent. But despite this, the paddle is intact and moves easily, and the switch still functions as intended, so I didn't ask for a replacement for it. I let my contact at Creality know about these issues. They've been brought to the attention of the appropriate department leader, and they're improving the packaging based on that feedback. So replacement parts are inbound, and in the meantime I have effective repairs to be able to use the printer. While overall the printer's components and workmanship are great, there are a couple of things that I'm going to group together as quality issues. This hot end and direct drive extruder assembly is unlike anything I've seen from Creality before. There's a 30mm fan that blows from front to back along the fins of a heatsink, and there's a blower on the back with a duct for parts cooling. And then there's another 30mm fan that blows across another heatsink from the side. Well, actually it's part of the same big block of metal that forms the first heatsink, but it's supposed to be cooling part of the filament path. The weird thing is, this second 30mm fan is wired in parallel with the parts cooling fan. That means it only runs and only cools that part of the filament path when the parts cooling fan is active. And I don't know why that is. I mean, I'm sure Creality had a reason for doing it that way, but what happens if you're printing PETG and you have the fan set to run at 30% speed? Or if you've got the parts cooling fan turned off for the entirety of a print? In that case, that heatsink fan isn't on, and heck, it may as well not even be there. But apart from that, the problem that I have with it is the fan on this particular printer doesn't always start when it's supposed to. It gets stuck, and I have to either blow on it or poke it with a screwdriver to get it to start spinning. So that's a quality control issue with that fan, regardless of the design decision to run the heatsink fan in parallel with the parts cooling fan. Another thing that I'm going to consider a quality issue is the tinned ends of the wires connected to the printer's main board for the power supply, heated bed, and nozzle heater cartridge. I talked about this in a recent video, so if you're interested in the why, you can check that out. So I cut off the tinned ends of those wires, stripped some of the insulation, and installed wire ferrules. And finally, there's not really a printer profile or settings available for Cura or any other slicer, so I had to develop my own, and I did it for Prusa Slicer. So if you want to download and use the settings I use, there's a link in the description. Here are some prints that I've done with the Sermoon D1 so far. I've got some benchies and calicats and bridging tests and stringing tests and aria dragons and a couple of leprechaun pots of gold, one regular size and one double size. These are all done in a variety of filaments. The sparkly green is Protopasta's Cloverleaf Green Metallic. This other one is a metallic silk rainbow PLA. Some of these are in Zero Marble PLA, and some are in Printed Solids Jessie PLA in the designed white color. I've got a few things I printed in some red TPU too, and those are nice and flexible. I made a couple of coasters and a traffic cone. The first traffic cone lost its grip on the bed and I had to restart it, but I was able to print the TPU at a good 35 millimeters per second. Now that's a little slower than I normally print PLA. I usually print PLA around 45 millimeters per second. I could probably go faster, but printing at 45 millimeters per second tends to give me good results without requiring me to think too much. Interestingly, the traffic cone has kind of a spiral pattern on the outside of it, and I think that's where it was changing layers. I probably should have had the slicer align the seam at the back, and then this would have been more like a zipper and it would have looked better. There's a teeny bit of stringing at times, but I'm also only using about 1.5 millimeters of retraction. This is direct drive, remember, so it doesn't need a huge amount of it. But overall, it's pretty good for some printer settings I've slapped together myself. Clearly, they could use a little more tuning, but again, it's not bad. I have never encountered a perfect printer, and the Sermoon D1 is no exception, so I'm going to get into the things that I think need improvement before I get into the things that I like. Now first, the bottoms of the side and back panels are only secured at the corners, and so sometimes the panels will rattle if the printer is making short, fast movements. That rattle could be eliminated if there were 1 or 2 attachment points at the bottom center of the panels. Now, it bugged me enough that I wedged a small strip of felt in there to cut down on the rattling, and that's worked fine. The printer is enclosed on the bottom and all 4 sides, but the top is open. It would be nice if there was an optional accessory you could buy to complete the coverage. Something like a clear hat that the printer could wear to keep the heat in for printing materials that warp unless they're printed in a heated chamber, like ABS for example. Some sort of lighting in the interior would also be nice. Maybe an LED strip mounted at the top of the frame to light up the inside. It can get kind of dark in there. Or maybe an LED mounted at the hot end to shine down on the print. But really, it's just begging to have some kind of a lighting solution inside. Let's see, what else? Oh, something to keep the filament spool from rubbing and scuffing the side panel would be nice. I think I can print something to hang between the spool holder and the panel to keep the spool away from the panel. But I get the feeling that when they decided to mount the spool holder here, nobody thought this was going to be a problem. Also, the breakout boards at the back corners could probably benefit aesthetically from some covers, just to conceal the wires and give it a neater look, but that doesn't affect the usability of the printer at all. Now I mentioned that fan that's part of the hot end cooling system, but runs in parallel with the parts cooling fan. In my opinion, that needs to run in parallel with the other hot end cooling fan that's on full time. And I mentioned the connections to the main board that carry a lot of power. The power input wires, the bed heater wires, and the hot end heater cartridge wires. They were tinned with solder. And again, I think these need wire ferrules instead. I've seen firsthand what happens to tinned connections that loosen over time. And now here are some of the things that I like about the Sermoon D1. Honestly, I really like the professional look of the thing. I know some people don't care what a printer looks like as long as it works well, but I find myself appreciating the way it looks. It's definitely one of the nicest looking printers that I have. The large touchscreen interface is well thought out and it's very usable. Some printer touchscreen interfaces are clunky and hard to use, but so far I've really been enjoying this one. File names shown on the screen only show the first 16 characters, so it would be nice if they could be shown in a little more length or detail when they're selected for printing, but that's about the only complaint that I have. When setting or adjusting temperatures, for example, a numeric keypad is presented on the screen. Just type in the temperature that you want and it's set. If you've ever suffered through setting the temperature by tapping an up arrow or a plus on the screen over and over, this interface is truly a blessing. This printer is one where I haven't missed using the old 128 by 64 graphical LCD with a control knob. Another thing I like is that all the electronics are mounted below the printing chamber. Now, it's not fully enclosed, so it's not going to be getting super hot in here, but if Creality begins offering a lid for this thing or you create your own, it's better to have the electronics where they can be properly cooled. And I also like the direct drive extruder. Another thing I like is that because the bed moves down instead of back and forth, I don't need a lot of extra space behind or in front of the printer like I do with my other big printers. And overall, it's reasonably quiet despite the Z-axis stepper motors. Most of the time, all I hear is the fans and a little bit of the motion system as the bearings ride on those smooth rods. To me, the noise level is on par with a laser printer when it's printing. So that's the Creality Sermoon D1 3D printer. To me, its looks are a step up from the Ender 3 and the CR series. But it's not all just about the looks. It's easy to assemble, the large touchscreen interface is easy to use, and it prints well. And it's one of Creality's few direct drive printers, so in addition to PLA and PETG, it handles TPU without a problem. Well, 3D printing friends, that's about all the time we have for this episode. And now that we're at the end, let's go print something cool. Hey, real quick before you go, I wanted to say thanks for being one of the super awesome people who sticks around all the way to the end, and thanks for all the likes, comments, and shares. And an especially big thanks to those who directly support what I do. You're all wonderful for doing that, and I really appreciate it. If you liked this episode, a thumbs up would be great, and if you'd like to help support the channel, check the description for ways you can do exactly that. And hey, if you haven't already subscribed, please do. It's absolutely free and it's an excellent way to help keep me making these videos for you. Well, that's it for this one. Thanks again, and I'll see you next time here on the BV3D channel.